All right, good morning, folks. Today we're going to go over section 10.7, which is talking about equations of circles. All right, before we do so, let's get started on some review problems. So in 1 and 2, we've got problems for angles within a circle and then segments about a circle. All right, so in the first one, we've got this angle being formed inside the circle. That angle should be the average of these two intercepted arcs there. All right, so that angle intercepts this arc. Okay, and if we look at the vertical angle, the other parts of that chord intercepts that arc. So that angle, 13x minus 6, should equal the average of these two arcs, which is 1/2 times the sum of those two arcs. So 15x plus 5 plus 60. We're running out of space here. All right, now the next step would just be to combine like terms. And then also we could get rid of that 1/2 by multiplying by 2 on both sides. So let's do that. Okay, so we'd get 26x minus 12 equals 15x plus 65. And then from there, we just got to get all of our variables on one side, all the constants on the other. So subtract 15x, we get 11x, add 12, okay, to both sides. We get 77. Divide by 11, we get 7. All right, so x equals 7 in this case. All right, let's check out number 2. Now I limited my space here, but we can do it. On number 2, we've got a secant relationship here. So these are segments formed outside of the circle here. And the first thing that we can do, remember for a secant relationship, exterior times whole equals exterior times whole. Okay, if you can see that. Right, so the exterior part of AC would be 7. Now the whole distance of AC, okay, would be, if we add those up, 24. That should equal the exterior times whole of the other segment. So if we look at EC now, the exterior part's 8, and then the whole thing would be x plus 8. All right, now pretty simple from here. So we can distribute the 8, multiply 7 times 24, we get 168. If we distribute 8, we get 8x plus 64. Now get our constants on one side, variables on the other. We get 104 equals 8x. Divide by 8, we get x equals 13. All right, so let's get into the meat of this lesson, which is talking about equations of circles. All right, so we're going to write and graph equations of circles, and you're going to have a really brief homework assignment on 10.7. All right, so if we get into it to start, all right, how we find the equation of the circle is just by Pythagorean theorem. All right, if we take a look at the picture here, okay, one thing that we know about a circle is that a circle just contains the points that are all equidistant from the center point, which in this case is going to be the origin. All right, so the thing that each one of those points on the circle has in common is the radius is 3, okay, for this circle and for all those points. All right, so that means the hypotenuse of the right triangle being formed is going to be r every single time. Okay, the x and y values may vary, but r is going to be the same every single time. All right, so if that r value is consistent, then we can get the equation of the circle by r squared equals x squared plus y squared. All right, in other words, if this is a right triangle here, we've got the hypotenuse squared equals one leg squared plus the other leg squared. Okay, so that would be our equation of a circle with radius r centered at the origin, which is the point 0, 0. All right, so it only works for circles centered at the origin. Okay, and note that r is the radius. So one thing that's different about this is in the equation we're going to see r squared. So you got to be aware that that's not r, that's r squared. All right, just like when using Pythagorean theorem. All right, so for writing the equation of the circle, one point to point out would be the center point. All right, notice that is on the origin. All right, we could easily find the radius more simply than doing anything else like finding diagonals. We just find that horizontal or vertical segment, all right, to find the radius. That way, all we got to do is just count. 1, 2, 3. So the radius in this case is 3. All right, so that's pretty simple in terms of writing our equation now. We've got x squared plus y squared equals 3 squared. 3 squared is 9. So boom, got the equation of this circle. All right, so when it's centered about the origin, it's really simple. All right, if it's not centered about the origin, it's a little bit more difficult. Okay, this still comes from Pythagorean theorem. Remember, in Pythagorean theorem, we have a squared plus b squared equals c squared, where c is the hypotenuse of that right triangle. Right, if we just think about a circle here, okay, where that would be r, right? The horizontal distance, okay, would just be the difference between the center, and what we're going to call the center is hk, and the x value. All right, right there, x minus h would be that the length of that horizontal segment of that triangle. Okay, for the vertical segment, okay, this is just our y coordinate here. This would just be k. That would just be y minus k. So when we're plugging this into Pythagorean theorem, a is just x minus h. B is just y minus k. And then obviously c is just r. So that's how we get this equation. Not that might be important to you. Maybe you just want to know how to use it. So we're going to go over how we use it. Things that we got to know is the center is h comma k. The radius is r in this equation, just like before. All right, so that's the standard equation of a circle on the coordinate plane. All right, so really simply, we're going to just go through some examples and where we're going to identify the center and then tell what the radius is. All right, so for part A, the center is going to be 5, 6. All right, you might be wondering, wait, why it says -5? Why is the x-coordinate 5? Okay. Remember, if we look back at those distances, we were finding the difference between those points. That's how we find difference. All right, if you want to find the difference between, your city and some other city, you're going to take a look at those locations, find the difference between them, all right, and that's how you find the distance. All right, so if that says x minus 5, that point is actually at 5. We were just finding the difference to figure out the distance. All right, and then for the radius, r squared is 49. So all we got to do is take the square root, and we'll get the radius. Obviously, the radius isn't going to be -7. We're talking about a circle. Okay, it's got a length, the distance between the center and the point on the circle. So it's got to be positive. All right, if we take a look at B, the center would be -7, 9. So when we see that plus sign, that's x minus a negative value. So that's why it's -7 here. Okay, it's the difference between that coordinate and -7. All right, and then for our radius, if r squared equals 81, r equals 9. If you got questions about this, please let me know. I'm going to pick up the pace on these last two. All right, the center for the next one is -2, -3. The radius is 1. In that case, r squared equals 1. When we take the square root, the square root of 1 is 1. All right, for part D, we're going to have 6, 0. Notice there's no change. All right, that value is going nowhere. So that y-coordinate is just 0. And then for the radius, this one's kind of tricky. A lot of people just write 7, but it's r squared, that's 7. So when we take the square root, we get the square root of 7. All right, that's how we can identify the center and radius given the equation. All right, what if we don't have the equation? What if we've just got some information here? So we've got the center and the radius. So we could just plug in what we know. So here's the standard form, standard equation for a circle. If we take a look at the information given, the radius is 4, all right, for our point here that we're centered at. That's going to be h comma k. All right, so we can just plug this in now. All right, so if we plug this in, we have x minus 2 squared plus y minus negative 9. I don't want to write that. I don't want to write y minus negative 9. Okay, so I'm going to write y plus 9 minus negative, same thing as adding. So now we have equals 4 squared. All right, just to simplify here, I'm not going to simplify anything else but the radius squared. Okay, the radius squared would be 16. So we have x minus 2, that quantity squared, plus the quantity y plus 9 squared equals 16. All right. The next ones, I know it says you try in your notes, but we're going to do these together. I'll do them fairly quickly. Let's check out part A. Okay, we have x minus 2 squared plus y plus 5 squared equals 4.2 squared. All right, this is our h, that's our k, that's our r. We're just plugging it into that equation. All right, if we do 4.2 squared, we get 17.64. All right, for the next one, notice there's no change, or our center, that x coordinate is already at 0, so that means we don't have to write x minus 0 squared. That'd be kind of redundant. It's not wrong if you do, but we just don't have to. Plus the quantity y minus negative 7, and instead of writing that, like we've said before, y plus 7 squared equals 10 squared. All right, 10 squared is 100, so we're just going to rewrite this, setting that equal to 100. All right, we just have a few more. All right, we have to go through all these different scenarios. Let's say we've got some information like the equation, and now we want to graph the circle. What I would recommend you doing first is identifying the center, and then after you find the center, figure out the radius. Okay, so the center in this case, if we look at the equation, we know whatever we're subtracting there is going to be h, so the x coordinate's 2. Whatever we're subtracting here is going to be k. All right, so it doesn't say subtraction, so inherently we're subtracting a negative, so that's negative 3. And then remember that this is r squared. You got to take the square root to get r equals 6. So we've got the center, so we can plot that center point to negative 3, and then use the radius. So from here, once again, we don't want to go in all different directions because we don't know how far 6 units is. Okay, so we're just going to count vertically and horizontally 6 units in each direction. So imagine you're on a map, you're going to go north 6 units. 1, 2, 3, 4, 5, 6, right there. South, 1, 2, 3, 4, 5, 6, right there. And east and west, same thing. So to the right, 6 units. To the left. Boom. All right. Now for the really hard part. If you're not a good artist like me, I'm not a good artist. Okay, so we're going to just try to do this. Oh, my shadow got in the way, so that's great. Try our best to draw a good circle. All right, the key thing about drawing a good circle, if I have any recommendation whatsoever, just coming from a bad artist here, would be to make it a little bit wider than what you think it would be. Okay, a lot of people will start to go like this, and then they end up forming something like a rhombus or a diamond or who knows what shape. So just make it a little bit rounder than what you think on those points on the circle, all these points. All right. So now we're going to write the standard equation of the circle given these 2 points. So that's tricky. We've got 2 points. Okay, one's the center point, our h comma k. Oops. And the other point is just some point on the circle. Well, the standard equation of the circle involves the radius. So the first thing that we've got to do is find the radius. So if we connect those 2 points, the center point and the point on the circle, we could find the radius using Pythagorean theorem. All right, notice that forms a right triangle. All right, and we could of course just use these points to find plug it into Pythagorean theorem, but instead we got a picture. So let's utilize that picture. All right, the difference between the x coordinates right here is just 4. We can count that right on the picture. Difference between the y coordinates right here would be 3. So r squared is just going to be 3 squared plus 4 squared. And note that all we need in the equation is r squared. We don't need r. It's not like we need to solve for r in this case. All we got to do is 3 squared plus 4 squared. All right, if we do that, we get 25. So that's all we need. Now we've got the radius, the radius squared, and we're going to use that center point, our h comma k, to write the equation. So that's going to be x minus our h value, which is -1, so x plus 1 squared, plus y minus 3 squared, equals 25. All right, and the last example, let's say, well, now we don't have a picture. Okay, we can still think about finding the radius as just the difference between the x's and the difference between the y's. All right, we don't really have to plug it into Pythagorean theorem. All we got to know is what's the difference between those x coordinates. From -1 to 1, that's 2 units. All right, the difference between 2 and 4, that's another 2 units. 2 squared plus 2 squared is just 4 plus 4. So all we need is that 8 now to write an equation. So we've got the center, our h comma k. I keep doing that, I don't know why. Now we're going to plug the center point and the radius in, so we get x minus 1 squared plus y minus 4 squared equals 8. All right, that's it, folks. I know I went a little long on that video, but once again, if you have any questions, let me know, and have a good day.